straightforward. Extension number is the number that you will want to use on internal dialing. Display name is the name that will be displayed to users on the same PBX. Outbound caller ID is the caller ID that will display on other users' caller IDs with displays outside of your PBX, so people like you would call outside, which this tutorial doesn't cover. Also have some various recording options and the secret password, which will also have to be shared with your device. Once you have all that filled in, just hit submit and click the red button. Second to last step of our journey here will be to add your inbound routing. And what inbound routing is, it will tell it what extension to send it to, or what digital receptionist, or what voicemail, or what queue to send it to. We're going to be sending it straight to our Sapura 2 box, which is running on the extension 1337, which is lead. And so I'm going to go hook this back up, and then we will demo that. Okay, so now that you have your hardware and your software and your soft phones and your hard phones and your asterisks and your IAXs and your free world dial-ups and your pulvers and all kinds of proxies and everything to tie it together, there's one thing left to do, which is to test your fruits of your labor and see if it actually works. We will be dialing mine, which is at 360-226-7313. Using my cell phone. You can use any regular house phone or anything like that. It's important to remember, since it is going through both the cell network and the internet and free servers, it will take a little bit while to connect, but it shouldn't take that long. As you can see, Free World Dial-Up has instructed my phone to tell this one to ring. We will answer and test it. Whoop. Whoop. And hang up. And as you can see, it works. This is all free software, free hardware for the most part, free services. Everything you see here is free. It allows people to call you from a regular phone and talk to you at your computer or at a regular phone for free. You know, this is a great way to kind of give it to the corporations and kind of, you know, AT&T and the big guys to kind of, you know, this is the wave of the future right here. This is IP telephony, and I think this will really take off. Anything you see here will be in the show notes, and if you have any questions, feel free to email me at will@techcentric.org, or see the contact page for any other form of contacts, and also feel free to call the number and leave a message on the voicemail that's sitting on that machine. I hope you have lots of fun with whatever voicemail and an asterisk will take you, and tune in next episode for outgoing calls for free. See you then.
So Will, that was pretty cool. How long have you been doing that for?
Well, the voice over IP stuff, I've been involved with phones for a while, but the voice over IP, I just kind of recently acquired that hobby. I watched System, and if you haven't seen System, which I'm sure everybody's seen System, I recommend going and seeing System. They have a good asterisk segment, and it really got me into asterisk.
Alright, cool. Well, coming up on our next segment, we're going to teach you how to do a real hardcore geek thing. Is actually read binary by hand.
That's cool stuff.
Mm-hmm.
Okay.
And today we're going to teach you binary. Binary, as you may know, is used most often in computers and networking, and is a numbering system based on 2 numbers as compared to our decimal numbering system that uses 10. Binary uses the two digits 0 and 1 to represent yes and no values and otherwise numbers as well. Now, to read binary, you just need to know how to use squares and powers of 2 and how to add. It's pretty simple math. We'll start off with a basic example: 1, 0, 0, 1. Now, going from the right, because that's how binary is read, going from the right, you're going to number your place values out: 2 to the 0, 2 to the first, 2 to the second, and 2 to the third. Now, calculating these out, 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. Now, we're going to look at the numbers from our original number, 1001. We're going to figure out what numbers we need to use. So, we'll go from the right again. We have a 1 in the 2 to the 0 column, so we'll mark a 1 there. We have nothing in the 2 to the first column, so we'll do nothing there. We have nothing in the 2 to the second column, so we'll write another 0 there. And we have a 1 in the 8th column, so we're going to put 8 here. 8 plus 1 is 9. So 1001 is the binary representation of the number 9. Now, we're going to go to something a little harder here. We'll do 6 digits. 0, 0, 1, 1. We'll renumber with our place values again. 0, 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. Because we have 6 digits here, and you always start with 0. We're going to again figure out what each one is worth. 1, 2, 4, 8, 16, 32. We're going to figure out what each number value is again. Starting from the right again, we have 1, we have a 2, we have nothing here, nothing here, we have 16 here, and we have 32 here. So top that all up. I'm going to break this down a little bit. We have 3 here, and 32 plus 16 is 48. So 48 plus 3 gives you a grand total of 51. So 110011 is the binary representation of the number 51. To conclude, binary is an alternate numbering system used in computers and networking. Uses the digits 0 and 1 instead of going through the whole spectrum of the decimal system we use, 0 through 9. It's used in computers because it can be used as logic, 1 being yes, 0 being no. And that about sums binary up.
So Steve, I hope you learned a thing or two from our good buddy Tavik there about hardcore, straight down lead hacksaw, reading binary by hand. Good stuff, huh?
Oh yeah, hot damn.
Hot damn, as Tavik likes to say. Next segment we have for you, we have a new addition to the cast, which is Jared, and he's going to introduce you how to use rainbow tables and different vulnerabilities. Check it out.
Hi, I'm Jared. I'm a recent addition to the show. I'm friends with everyone from the show as well. So what today I'm going to be teaching you all about is rainbow tables. So first off, we need to define what a rainbow table actually is. Wikipedia defines a rainbow table as a lookup table that has a simple plain text password. It has ciphers and keys in it, and it's generated by a one-way hash. So the point of the rainbow table is simply like a brute force attack. It just basically goes through all this sort of stuff. It basically just goes, it repeats a number of words to get the password. However, unlike the brute force attack, rainbow tables are actually pretty fast. What we're going to use today to crack the rainbow table is OPH crack. And it's from a live CD of Ubuntu. And basically it takes 10 minutes to load because it is a live CD of Ubuntu. So we're going to basically wait for that to load. It's going to take about 10 minutes, so we'll be back in about 10 minutes. And we're back, and it's now loaded up. So it's basically loaded up all this stuff on there, and all we have to do is just move the mouse over, click it, and it's going to scan. It's going to take about 10 to 15 minutes to scan. So if you're going to basically try to crack any of this stuff, say on your parents' computer or your brother's computer, it's going to take maybe about half an hour at minimum to do this sort of stuff. So make sure they're not in the house. So it's basically now just cracking that stuff. So we're going to come back in about another 10 to 15 minutes after it's cracked. We're back, and it's now cracked all the passwords, so we now have all of the passwords for Mr. Tavik's computer. And it turns out that his password is tech. So the whole point of the rainbow table, like I said before, is just like a brute force attack. It's just going to go through these things and just attack it. However, there is one or two discrepancies about it. Most versions of Unix